The larger the diameter of a wire, the lower its resistance will be. And this is because the charge carriers, which make up the current, have got more paths along which to flow if the diameter is bigger. Compared to a small diameter wire, there's only a few paths that the charge carriers can flow down. Another way to look at this is just like a motorway versus a normal small road. You can fit a lot of cars per second flowing down this motorway compared to this smaller road. And so this is like the large diameter wire compared to a small diameter wire. We can fit an awful lot more traffic, if you like, or charge carriers down the larger diameter wire. So let's put that into words. The larger the diameter of a wire, the lower its resistance will be. This is because ... the charge carriers, and in this case for a wire it will be electrons, the charge carriers have more paths along which to travel. They have more paths. That's the key word here. What about if you make the wire longer? The longer the length of a wire, then the greater the wire's resistance will be. Now, why is that? To understand this, we need to take a look at what's going on inside a wire, a metal wire. Now, a metal wire, the structure of metal is a lattice of positive ions, positive metal ions, in a sea of freely moving electrons, or what we call delocalized electrons. That's a good phrase to remember. A lattice of positive metal ions in a sea of delocalized electrons. Now, these positive metal ions cannot move. They are the atoms. They're held in place. But these electrons are buzzing around like little pinballs, bouncing into the atoms, bouncing off. And when a current flows, it's like you apply a pressure to one side of the wire. That's the battery. And that makes these electrons drift to the right, and a current will flow. They're still bouncing backwards and forwards, but they're drifting on average to the right. So every time they collide with an ion, the electrons can lose some energy. So the energy they've been given by the battery, as they travel through a resistor or resistance wire, they will lose some of that energy, and it will be given off as heat or vibration of the ions. So if we made the wire longer, then there will be more collisions of these electrons with the ions, and so they will lose more energy. And that's why increasing the length of a piece of wire will increase its resistance. So let's put that into words. So this is because ... there will be more collisions with the metal ions. There will be more collisions with the metal ions by the flowing electrons, let's put, by the flowing electrons, and they will lose more energy. Okay. The larger the diameter of a wire, the lower its resistance, but the longer the length of a wire, the greater its resistance, because there'll be more collisions. There's double the length, you've got double the amount of collisions.